And if you say to me, I had 2.9876 siblings, I'm going to back away slowly.
Continuous.
You guys with me? What are the only possible values for that question?
Discrete.
0, 1, 2, 3, right? So that would be an example of discrete. It's not continuous because the answer cannot take any value in a continuum. So what would be something on a continuum? Almost every measurement. Because that could be more and more precise. If you said your backpack weighs 8 pounds, does it weigh exactly 8 pounds? Probably something like 7.6294733333331 pounds. And does that still make sense to say that? Yes. Whereas if I said I have 3.7 pets, I'm not going to your house. What's that one pet doing? Oh yeah, like 30% of the time it phases into another dimension. I'm not. I kind of want to see that. But still, you wouldn't say it's a part of a pet. You know, I got 2.5 kids because this one lost. Come on, lost 2 of his limbs. That's evil. I love it. Sorry, I could be a little dark. I'm sorry. You guys kind of see what I'm saying? You wouldn't say it's half of a person because they lost something, right? Okay. All right. Maybe some evil person would, but let's say most rational and normal people would not do that. You're half a person. Oh yeah, you can still bite your knee. Yes.
So for change that was like money, that would be considered continuous, right?
Why?
Because you can have like $2.
This is a beautiful. You ready? It's not because it has a decimal. Can it take on any value? So if I gave you change back, could I give you 2.97346669722293111 cents? No, right? Right, or dollars in that case, right? I can give you $2.97 in change, couldn't I? I can give you $2.98 in change. Didn't I just jump over a ton of possible values? So that would be discrete. So it's not as easy as this. Unfortunately, it's not discrete, has its whole numbers, and continuous is decimal. That's bullshit. I'm sorry, I don't mean to come down to you, but just to really make the point, it's do the possible values skip things. So how many doors can you have on a vehicle? Some of you guys realize you actually have vehicles that have half doors, right? They do. They call it a half door. Like on a truck, you have this little door that's like an afterthought. Oh yeah, let's put it. Oh yeah, squeeze it. Right? You get this half door. So you could have like 3.5 doors in your car. That's great. You with me? But could you have 3.187 doors? Because that one works about 18% of the time. No, it's still a door. You with me? Or not? Okay. So it's not decimal makes it continuous. Could it possibly be more and more decimal places and still make sense? Could it take on any value between two numbers? Yeah?
Oh, I was just going to clarify. So it doesn't have to be a decimal, but in your head to have it make sense.
Beautiful.
Think about.
Because this kind of example, the kind of problem I give you is, he said his backpack weighs 8 pounds.
Okay.
People say it's discrete because they see 8. Wrong. Right? If I said, how far away do you live? You would say like 11 miles. You're not going to say 11.273 miles away. Because I'm going to be like, you're an interesting person. Right? I love Google Maps. You're awesome. All right. Right? So how do we say things doesn't change what kind of variable it is? It's a continuous variable, distance to your house, because it could take on any value between 0 and whatever. If you live in that chair, it'd be 0.
And distance is a measurement.
Yeah. So be careful. Not every measurement is necessarily continuous, but almost all of them are continuous because you can measure more and more precisely. Yeah.
So distance is continuous, huh? Distance.
Totally. Distance would be height, length, weight, volume, because you can be more and more precise. Whereas I would say number of pages in a book is a measurement, but it is not continuous. Well, that page only has 7 words. It's a page. You just said it. So it's not 0.2 of a page. I ripped it. Yeah. Now it's a ripped page. So it's still a page. All right. Yes. Yes. Okay. Good. Is the heat on?
It feels like it.
What are you doing? So it says cool. All right. I'm gonna put this up. I can never remember if this is down or up, which one's better. If it gets warmer, I'll put it back down. Because of course the intake is right there behind the screen. That's completely awesome. Excellent design work. All right. So let's see. Here we go. Making up data. Making up data. All right, let's play. All right, sure. It's a very small data set, but who cares? God, it's hot. It is. Well, hopefully we'll see. All right, so what's the first step to create a histogram? What controls everything? Class width. That gets everything going. So how do I calculate class width? Yeah, range.
Divided by number of classes.
And how many classes you guys want to use? Anybody want to use 4 classes?
Yeah.
No, you failed already. What's the lowest number of classes you're allowed to use?
5.
And the most you can use is normally about 10. I'm never going to give you a big enough sample to really use 10. That'd be evil. Here's 800 numbers. That's problem number 1. What's the range?
32.
Yeah, 42 minus 10. I like it.
32.
And let's use how many classes you think? Very small sample set. 5. So what's 32 divided by 5? And I told you this trick, right? You divide by 5, double this, and then move the decimal back a place. Because if you double it, it's 64 over 10, and how you divide by 10, move the decimal back. 64, move the decimal back, 6.4. And again, some of you guys are like, I got this thing. What do I do with that?
Round
All right. So, now I go to construct my classes. So I think most of you guys use the textbook method. So I have some flexibility, but pretty much you should start where here? What's the first data point?
The lowest one.
Yes, so start at 10. So where should the next class start? 17. So what should this go up to?
10 to 16.
16, and then you just keep adding 7. All right? Once you get this much set up, 10, 7 away, 1 down, just to keep adding 7 on both sides. Because that's the width. Yeah, good job. And a quick check, what's the biggest data point? Does it have a home? Yes.
Yeah.
Yes.
So, like the example you have, like the midpoints, the ones that are just like single digits. If you wanted to do it the method with like the inequalities, could you then just put the classes as like with the inequalities and just like which is 4, 4, 2, 5, or would that be wrong?
So if you do it the other way, I don't know if I can see all this up here. If you do this class the other way, it would look like this, right?
But I mean for like the ones that are, so you remember the example where it was just 3, 4, 5, 6, 7?
Yes, yes.
Could you just do 3 to 4, like have the
No, definitely not. Because, I mean, if you have 3 to 4 with a bar, that bar, is it the 3 bar or the 4 bar, is not easy to tell.
But it's like 3 is less than or equal to x, which is less than 4, so it's not considered technically 4 yet.
Oh, I see. So you could argue a little bit there, but I'd still say no.
Okay.
Because the bar's definition should be discovered in the middle, and this is not the 3.5 bar. Yes.
Could you explain real quick why we have to have 5 classes is the minimum?
It's just generally accepted that for most data sets, less than 5 doesn't show enough resolution. If you have too many classes for a very small data set, there's gonna be like one data point, or I'm sorry, too many, yeah, that's right. If I have too many classes for a small data set, they might all just be one thing big. It's like, yeah. So sort of, yeah, it's getting hotter, right?
Yeah.
All right, so I gotta trick this thing. Why?
I feel like it broke. When the lights flickered, that's immediately.
Yeah, it's a good point. That could very well be true. I think you might be correct. What time is it? Oh, yeah. Let's see how long you guys can handle. I have to call these guys. All right. What goes up here? This is learning stats in a sauna.
2.
Sauna. 2. 1.
3.
4.
2.
2. Sucks. Yes. Oh, okay. And again, so very physical thing. I've got the width has got to be 6.4 to perfectly fit the data. If I make it smaller, it's not going to be wide enough total to get all the data in. So I over cover the data instead of under. It's like having a blanket that doesn't cover your feet. Like you'd rather have a blanket that over covers your feet. How many data points is there?
11.
Yeah, and this adds up to 11. Thank God. Everything matches. So what's the relative frequency here? 2 out of 11. 1.8 roughly. Or 0.1, yeah. So 18% roughly. 1 out of 11 would be roughly 9%. Isn't that neat? Yes.
36.
Yep, because 4 would be twice 2, so it's twice 18, so it should be roughly 18 twice. Is it 36%? Okay.
Yeah.
And then 2, we already know that shit. 18%, 18%. Oh my God. I'm not entirely sure. I gotta figure out who to call. Maybe I'll try to call here in a minute.
So if it adds up to 99 or 100, you
Yeah, within 1% of 100 should be okay. So this adds up to 99?
yeah.
Okay. Because I'm sure this is like 18 point something. Yeah, so we just left off the point shift. Alright, so. Oh God, this sucks. And now, what do I put down here based on how I set this up? Yay, it's even hotter now. They locked me out of the damn thing.
Not even that hot.
Yeah.
Hey, you guys finish this up. Let me figure out who to call.